Your body isn't trying to make you overweight, it's trying to keep you alive. In the next few minutes, you'll understand why. Right now, somewhere in your skull, a walnut-sized structure is running a calculation older than your species. It doesn't know what a grocery store is. It doesn't know what a vending machine is. It has never heard of a drive-thru, and yet it is, at this exact moment, deciding whether you are allowed to feel satisfied. This is the hypothalamus, and it is not asking whether you've eaten enough. It is asking a much older question: are we about to starve? For nearly the entire span of human existence, that question had a simple, brutal utility. Food was scarce. Effort was constant. The body that could store the most energy the fastest and defend that stored energy the most fiercely was the body that survived the next famine. Obesity, in the strict biological sense, is not a malfunction. It is a system operating with terrifying precision just aimed at a threat that, for most of you watching this, no longer exists. Let that settle for a moment. The mechanism protecting you from starvation 200,000 years ago is the same mechanism sitting in your brain today, unaware that starvation isn't coming. It never got the memo, and it is not going to update its threat model just because you've read a nutrition label. Here is where the illusion cracks. You have been taught to think of hunger as a simple signal. An empty stomach sends a message, you eat, the message stops. That model is almost insultingly incomplete. Hunger is not one signal. It is an entire negotiation between at least a dozen hormones, each one voting on whether you are safe enough to stop eating. And one hormone, more than any other, has been quietly rigging the vote. Its name is leptin. It is secreted by your fat cells, your adipocytes, in direct proportion to how much stored energy you're carrying. More fat, more leptin. In a body working correctly, this is an elegant thermostat. Leptin rises, travels to the hypothalamus, and delivers a simple instruction. We have plenty stored. You can stop seeking food now. It is, quite literally, a satiety hormone broadcast directly from your fat reserves to your brain. But here is the paradox that should stop you cold. In obesity, leptin levels are not low. They are often extraordinarily high. The fat cells are screaming the message, and the brain isn't hearing it. This is called leptin resistance, and it is one of the most consequential discoveries in modern metabolic science. The receptors in the hypothalamus that are supposed to detect leptin become desensitized, the same way your ears stop registering a background hum after enough exposure. The signal is present. The reception has failed. And when the brain stops hearing, "we have plenty," it defaults back to its oldest, most primal interpretation of silence. We must be starving, seek food, conserve energy, slow the metabolism, increase hunger. Think about what that means for a person living inside this loop. Their body is, by every internal measurement, running a famine response, increased hunger signaling, decreased energy expenditure, heightened food-seeking behavior, while simultaneously carrying substantial energy reserves. The brain and the fat tissue are no longer speaking the same language. It is not a failure of discipline. It is a communications breakdown at the cellular level, and no amount of willpower rewires a broken receptor. Now look at your own body for a second. Somewhere beneath your skin, adipose tissue is doing something far more sophisticated than simply storing fat. Each adipocyte is a metabolically active endocrine cell, releasing not just leptin but a cascade of signaling molecules: adiponectin, resistin, inflammatory cytokines like TNF-alpha and IL-6 that ripple outward and influence insulin sensitivity, blood vessel function, and systemic inflammation throughout the entire body. Fat is not inert padding. It is one of the largest hormone-producing organs you possess. And when it expands beyond a certain threshold, its chemical output starts working against the very system it's supposed to protect. This is where the physics enters the story. Every calorie you consume is a unit of stored chemical energy, a package of potential work bound up in the covalent bonds of fat, carbohydrate, and protein molecules. Your body is, at the most fundamental level, an energy conversion machine operating under the same non-negotiable law that governs every closed system in the universe. Energy cannot be created or destroyed, only transformed and stored. When intake exceeds expenditure, that surplus energy has to go somewhere. The adipocyte is where the universe's accounting gets settled, one triglyceride molecule at a time. But, and this is the part almost never taught, the adipocyte is not a passive container. It is more like a bank vault with an alarm system that gets more sensitive the fuller it gets. As fat cells expand, they don't just grow larger. New cells recruit and differentiate, and existing cells begin secreting more of those inflammatory signals. The body starts defending its current fat mass as though it were a set point worth protecting, a concept researchers call the settling point, or set point theory of body weight, which we'll return to in devastating detail later in this video. For now, hold this thought. Your hunger tonight is not a character flaw. It is a 100,000-year-old survival algorithm, misfiring in a world engineered by abundance. And in the next 10 minutes, we are going to follow that misfire down into the bloodstream, into a single molecule of sugar, and watch exactly what happens in the 60 seconds after it enters your body. Here is a sequence that happens inside you dozens of times a day, and you have almost certainly never watched it unfold. You eat something sweet, a piece of bread, a soda, a candy bar, it doesn't matter which. Within seconds, glucose molecules begin crossing from your gut into your bloodstream, and your pancreas detects the rise before you've even swallowed the second bite. Specialized cells in the pancreas, the beta cells of the islets of Langerhans, respond by releasing insulin, a hormone whose entire job is to unlock the doors of your cells so glucose can move out of the blood and into tissue, where it can be used or stored. Insulin is not optional. Without it, glucose stays trapped in the bloodstream, and the results are catastrophic. This is, in essence, the mechanism behind type 1 diabetes. But in a body still working correctly, insulin performs its task with remarkable speed. Within 60 seconds of a sugar spike, insulin is already circulating, already binding to receptors on the surface of your muscle, liver, and fat cells, already triggering the translocation of glucose transporters to the cell membrane. Now here is where the story bends. If your muscles and liver are already saturated with stored glycogen, which, in a sedentary, calorically abundant lifestyle, they very often are, that glucose has nowhere efficient to go. So the body redirects it. Insulin, in addition to ushering glucose into cells, is also a powerful lipogenic signal. It tells your fat cells to absorb fatty acids from the blood and convert incoming glucose into triglycerides for long-term storage. This is not a bug in the system. This is insulin doing exactly what it evolved to do, aggressively banking energy the moment it becomes available, because for nearly all of human history, availability was never guaranteed. But repeat this cycle enough times a day, every day, for years, and something insidious happens. The cells that are supposed to respond to insulin's signal, the receptors on muscle and liver tissue, begin to dampen their response, the same desensitization phenomenon we saw with leptin in the brain. This is insulin resistance. The pancreas, sensing that glucose still isn't being cleared efficiently, compensates by releasing even more insulin. Blood insulin levels climb chronically higher, and because insulin is such a potent signal for fat storage, chronically elevated insulin means chronically amplified fat storage, even independent of dramatic increases in eating. This is the invisible war happening in your bloodstream every single day, a rising tide of insulin, fighting cellular resistance, while simultaneously commanding your fat tissue to keep absorbing and storing. Two hormonal systems, leptin in the brain, insulin in the periphery, both becoming less effective at exactly the moment they're needed most, both responding to that failure by escalating their own output. It is a feedback loop turning against itself. Now let's go somewhere almost nobody talks about, the brain's reward circuitry. Food is not just fuel. It is one of the most ancient and powerful triggers of the dopaminergic reward system, the same neural pathway implicated in every form of compulsive seeking behavior. When you eat something dense in sugar and fat, a combination essentially non-existent in nature outside of rare items like honey, but manufactured relentlessly by modern food engineering, your brain's ventral tegmental area releases dopamine into the nucleus accumbens, generating a surge of reward-driven motivation. Functional imaging studies have shown that highly palatable, energy-dense foods activate these same circuits with an intensity that rivals substances explicitly designed to trigger addiction pathways. This matters because the modern food environment was not designed by evolution. It was designed by companies, engineers, and food scientists, optimizing for exactly one outcome: maximal reward, minimal satiety, repeat purchase. The combination of refined sugar, refined fat, and salt at precise ratios creates what researchers sometimes call a hyperpalatable profile, engineered to overwhelm the very hunger and satiety signals we just spent 10 minutes describing. Your leptin system is trying to tell your hypothalamus you're full. Your dopamine system is simultaneously telling your prefrontal cortex that the reward is worth pursuing regardless. In a chronic mismatch, reward wins because reward seeking is older, faster, and more deeply wired than deliberative satiety calculation. Layer onto this one more physiological detail: chronic stress. Cortisol, the body's primary stress hormone, does something specific and often overlooked. It increases appetite, particularly cravings for calorie-dense food, and it preferentially promotes the storage of visceral fat, the metabolically active fat surrounding your internal organs. In a world of chronic psychological stress, financial pressure, social comparison, sleep deprivation, cortisol is elevated far more consistently than it would have been for most of human history, where stress was typically acute and short-lived, tied to an immediate physical threat, rather than a sustained psychological one. So picture the full architecture now: a hypothalamus no longer hearing leptin's satiety signal, a bloodstream locked in an escalating insulin battle with resistant tissue, a reward system hijacked by engineered hyperpalatability, and a stress hormone tilting the entire system toward increased appetite and increased fat storage. None of these systems are broken in isolation. Each one is functioning according to its original design. It is the collision of all four inside a food environment, unlike anything in evolutionary history, that produces the outcome we call obesity. And this brings us to the deepest layer of the story, the one written not in biology, but in physics. Zoom all the way out now, past the hormones, past the neurons, past the individual body entirely, and look at the law underneath all of it. The second law of thermodynamics states that in any closed system, entropy disorder tends to increase over time, unless energy is deliberately expended to maintain order against that tendency. Your body is not exempt from this law. It is, in fact, one of its most extraordinary demonstrations. Every second you're alive, you are fighting entropy, maintaining the astonishingly improbable order of a living organism by continuously importing energy and exporting waste and heat. Fat storage, viewed through this lens, is not decay. It is order. It is your body successfully, efficiently converting a chaotic influx of dietary energy into a stable, organized reserve triglycerides, densely packed, chemically inert, ready for deployment. In a strange way, obesity represents your metabolic machinery succeeding at its thermodynamic job with almost frightening competence. The tragedy is not that the system failed. The tragedy is that it succeeded too well, for too long, against a caloric tide it was never built to hold back. This is where we have to talk about set point theory, because it explains something that frustrates almost everyone who has ever tried to lose weight through sheer caloric restriction alone. The body appears to defend a certain range of stored fat mass with remarkable tenacity, not through conscious will, but through automatic, coordinated hormonal adjustment. Cut caloric intake significantly, and the body doesn't simply comply. It responds as though under genuine threat, resting metabolic rate drops, sometimes far more than the reduced calorie intake alone would predict, a phenomenon researchers call adaptive thermogenesis. Hunger signaling intensifies, levels of the hormone ghrelin secreted by the stomach to stimulate appetite rise. Leptin, now reflecting the newly reduced fat stores, falls, further amplifying hunger while further suppressing energy expenditure. The body is not resisting change out of stubbornness. It is executing a defensive protocol precisely tuned by millions of years of selection to protect against what it interprets as a life-threatening famine. This is the cruel mathematics that pure willpower can never fully overcome. You are not negotiating with your conscious mind. You are negotiating with a survival system that predates language, predates agriculture, predates almost every technology that created the caloric abundance now working against it. Losing stored energy, biologically speaking, has always meant losing insurance against death. The body defends that insurance fiercely, automatically, and largely outside of conscious awareness. Now bring in the evolutionary mismatch directly. For the overwhelming majority of hominid history, caloric density was rare, and caloric acquisition required significant physical effort: hunting, foraging, walking miles for a single meal. The genes that promoted efficient fat storage, powerful reward responses to sugar and fat, and aggressive hunger signaling during scarcity were not liabilities. They were the genes of survivors. They were selected for, generation after generation, precisely because they worked. Then, within an evolutionary blink of an eye a few hundred years, a fraction of a single % of the time modern humans have existed, that environment inverted completely. Caloric density became nearly unlimited. Physical effort to acquire food dropped towards zero. The same genetic programming that once meant survival now operates inside a world engineered, quite literally, to exploit every weakness in that programming for profit. This is not a story of individual failure. It is a story of a magnificent survival system, perfectly calibrated for one world, suddenly deployed into another it was never designed to navigate. There's one final piece of this puzzle worth holding on to, and it comes from an unlikely source: information theory, first formalized by Claude Shannon in 1948. Shannon's central insight was that any communication system, a phone line, a radio signal, a nervous system, has a channel capacity, a maximum rate at which information can be reliably transmitted before noise begins to corrupt the message. Apply that lens to the hormonal signaling we've spent this entire video tracing. Leptin, insulin, ghrelin, cortisol, dopamine, these are all, in the most literal sense, information channels, each one carrying a message from one part of the body to another. Chronic overexposure, chronically elevated insulin, chronically elevated leptin, chronic inflammatory noise from expanded adipose tissue doesn't just fail to deliver the message, it functions exactly like signal noise flooding a channel past its capacity, degrading the fidelity of the message until the receiving system can no longer distinguish signal from static. Resistance, at every level we've discussed, is a communication channel overwhelmed by its own volume. So return, one final time, to that walnut-sized structure in your skull, still running its ancient calculation. It was never lying to you. It was never broken. It has simply been asked to interpret a signal flood that no organism in the history of your species has ever had to decode before, and it is doing its honest, best, thermodynamically rigorous attempt to keep you alive inside a world running on entirely different rules than the one that built it. That is not a moral failure. That is not a lack of discipline. That is biology, running exactly as designed, inside a world that changed faster than the code inside you ever could.